Rationalizing denominators. So, one of the issues that we have in classic mathematics is the idea of dividing by an irrational number. So, I'm going to rationalize this function, meaning I have that radical, that square root in the bottom of the fraction or the denominator, and that causes some problems. As you move up and higher in mathematics, it becomes less and less of an issue, but it really does, it is something we have to be able to deal with. So what I need to do is multiply the denominator times an identical radical. Okay. But I can't just do that because if I multiply the bottom by root 3, and I'll show you why I want to do that here in a second, it would change the value of the fraction. So I have to multiply the same thing to the top and the bottom, which is really just a 1. Means I multiply by 1. Okay. And when I do this, I multiply the tops and the bottoms, right? It's how you multiply a fraction, and that's what I'm going to get right there. So why did I want to do this? Watch what happens in the denominator. So if I multiply two radicals, I can put them underneath the same radical, right? And then a square root and a square inverses. That's a perfect square. And then it's going to be just 3. Okay. So what I need to be able to realize is I got to multiply by the bottom, the same denominator that's in the bottom. However, I got to make sure that I do it to the top and the bottom so that the fraction remains the same value, even though the numbers look like they're changing. Okay. 5 over root 7. So I'll multiply by 1. In this case, it's going to be root 7 or root 7. Right? Remember, I want to multiply as the same radical in the bottom. I don't care about radicals up on the top. It's just in the denominator. Right? Multiply straight across. And that's going to be... I'm going to be able to put those radicals, right? The 7 underneath one radical. 7 squared, and that's just 7. Okay. So if we were doing this on a homework assignment or a test, I really have no problem going from right here from this root 7 all the way just to this 7. You don't need to show these intermediate steps here, but I want to see it. I want you to be able to see it in the notes and why this is actually happening. Because when we start introducing more stuff, this does get more complex. Okay, this plays very nicely when there's no plus or minuses or binomials or polynomials in the denominator. In this case, these are pretty simple. We want to kind of get ready for the more difficult ones. 11 over root 13, same process. I don't care what's going on in that numerator. When I'm rationalizing, and keep this in mind, when I'm rationalizing, I'm not simplifying this fraction. I'm not making it less simple. I'm not like reducing, 8 over 16 to 1/2. What I'm doing is just I'm setting it up so I'm not dividing by an irrational number. So I'll multiply by root 13 over root 13, right? Multiply the tops and the bottoms. And remember, when you multiply a whole number times a radical, it's just going to be 11 root 13. They just put them next to each other. Those go underneath the same radical, right? There's my perfect square, and I get a 13 in the denominator. Okay. So what does this really mean? 11 divided by the square root of 13 is the same thing as 11 times the square root of 13 divided by 13. Right, we're going to use this quite a bit as we deal with more and more fraction stuff. All right, kind of going here real quickly now that we hopefully see the pattern. So I'll multiply by the square root of 5 over the square root of 5. Multiply the tops and the bottoms, right? Numerators, denominators, right? We should hopefully be able to jump pretty much to this end down here. So remember, multiply by the same radical that is in the denominator. All right, I think we're good with that. Okay, so let's look at something like this one. Well, actually, I think I want to go back. Sorry. Let's look at this. Okay, so here's where an additional step is going to come in, and this is the question I was actually looking for. So let's go through the same process. Multiply by root 2 over 2, right? Everything's the same so far. Multiply straight across, right? And then I get, right, the 2's underneath the same radical, and I get my perfect square. So now this is where things are different here. So in this case, now I'm able to reduce the 10 over the 2. Those reduce. This is all multiplication, so everything can reduce. So 10 divided by 2 is 5. Okay, I can't reduce a radical 2, this square root, and the regular 2, but this 10 and 2 reduce. So just be careful when you're done rationalizing. You may end up with a little bit of simplification at the end. All right. So 2 all over the square root of 8. So same thing, I'm going to multiply, all right? However, if you look what I did here, before I did that, I actually simplified the root 8. Okay, root 8 is the same as root 4 times root 2. Okay, and then that square root of 4 is 2, right? Then I can reduce the 2's, and then I get 1 over root 2. So this is simplifying. This is not rationalizing. I simplified. 2 over 8, root 8 is the same as 1 over root 2. Now I'll rationalize it. Multiply by the root 2 over 2, right? Multiply straight across, and I end up with root 2 over 2. Okay? So basically, 2 over root 8 is the same as 1 over root 2, and 1 over root 2 is the same as root 2 over 2. Looking at all three of those different fractions may not make you believe that, but that is true. Okay? So we may have to simplify the radical first. You could actually do this at the end. Either way, you're going to have to do some simplifying.